In the abyss beyond the reach of suns, a signal drifts. It moves without hurry, without pause, threading its way through the silent corridors of interstellar night. It began long before continents rose from the sea, before the first green breath of forests, before even the earth itself cooled from its molten youth. It is older than memory, older than loss, older than the concept of time as humanity understands it. The star that forged this whisper is gone now, extinguished, dismantled by the quiet machinery of cosmic decay. Its atoms have scattered into the darkness, reclaimed by the vast, indifferent sea from which they came. Yet the message it once hurled into the void remains intact, gliding onward with unwavering purpose, or perhaps with none at all. It does not speak in words, for words are the inventions of fleeting creatures. It speaks in the pure, unbroken language of physics, a ripple in the electromagnetic field, a vibration set loose upon the tapestry of space-time. It carries no urgency, no plea, only the immutable fact that somewhere, long ago, a thing existed, and in existing, left behind a trace that refuses to die. And therein lies the mystery. How can something endure when its origin has already been erased from the present? In the infinite theatre of the cosmos, where matter burns and fades, where galaxies are born and devoured, this signal is a stubborn defiance of finality. This is not merely the story of its journey, it is the story of time itself, of echoes that outlast their sources, of moments that refuse to be forgotten, a fragment of reality frozen in flight, still unfolding in the darkness. It began, as many great astronomical revelations do, with an attempt to study something entirely different. The mid-20th century was a turning point in humanity's vision of the cosmos. Radio astronomy, still young, still clumsy in its infancy, was beginning to stretch its reach beyond the confines of our solar system. Large steel dishes rose from remote valleys, their parabolic arms reaching for signals that no human eye could see. These were not telescopes for light, but for the hidden murmurs of the universe, the faint hiss of quasars, the rhythmic heartbeat of pulsars, the ever-present afterglow of the Big Bang itself. It was in such an age that a certain pattern emerged, not in the blinding glory of a supernova's light, nor in the gravitational dance of a nearby planet, but in the thin, fragile thread of a radio pulse, so faint it skirted the edge of detectability. The location, a modest but capable observatory, far from the interference of cities, where the air was clear and the ground still hummed with the quiet of nature. The year one when humanity's gaze was turning outward with unprecedented ambition, satellites circling the Earth, probes touching the moon, and the first serious scientific attempts to listen for voices beyond our world. At the time, the astronomers were searching for pulsars, collapsed neutron stars whose magnetic fields and rapid rotations send beams of radio energy sweeping through space like the beam of a lighthouse. Their signals arrive on Earth with remarkable regularity, a ticking clock in the night sky. The instruments had been tuned to isolate these rhythmic patterns from the noisy chaos of cosmic static. But then came the anomaly. It was not the crisp, repeating beat of a pulsar. It was not the random, unstructured hiss of background radiation. Instead, it was something in between, a steady, coherent emission that refused to match any known natural template. The first to notice was a young researcher monitoring the array's early data stream. At first, she dismissed it as interference from terrestrial transmitters, a passing aircraft, perhaps, or a burst from an experimental satellite. Yet the signal persisted. Not loud, but persistent. Not random, but ordered. The team recorded the event and adjusted the array's aim. Hours later, it was still there. Days later, still there. Even weeks later, the signal lingered, unchanged in its slow, measured arrival. And yet, when optical telescopes were pointed toward its origin, they found a patch of sky devoid of anything remarkable. No shining star, no blazing quasar, nothing at all but a dim scattering of distant galaxies, each too far to match the timing of the detected emission. It was then that a subtle truth emerged. This was not a message from the present. This was light, or more precisely, radio, that had begun its journey in the deep past. Calculations based on its frequency shifts suggested that it had been traveling for tens of thousands, perhaps millions of years. By the time it reached Earth, the source from which it came had ceased to exist in any recognizable form. The region of sky was not empty because the astronomers were wrong. It was empty because the star had already burned out long before. The human species arose to see it. What they were witnessing was a ghost. Not a ghost in the sense of supernatural invention, but in the strict, cold language of physics. A relic of an event still unfolding in our detectors, though the event itself was long over. Just as we can see the sun as it was 8 minutes ago, so too were these scientists now seeing, hearing, the deathless echo of something impossibly ancient. The observatory confirmed the finding with repeated measurements. The signal's amplitude, though faint, was unwavering. Its frequency drift was minimal, consistent with a source that had once been steady in its emission. Other observatories were contacted first regionally, then internationally. One by one, they aligned their dishes to the coordinates provided. One by one, they confirmed the same astonishing truth. The signal was real, and it came from a place where the source no longer was. It was an entirely natural outcome of light's finite speed, and yet it carried an emotional weight that no mere equation could contain. Here was the undeniable evidence that the past still exists, not metaphorically, but physically, as tangible energy moving through the universe. The only difference is that we cannot touch it, only receive it when it happens to arrive at our small, spinning world. The news moved quietly through scientific circles, discussed in conferences, published in careful journals. There were no tabloid headlines, no fevered public speculation. Not yet. It was, after all, just a signal. And yet, for the scientists who had seen the raw data, it was more than that. It was a reminder that in studying the universe, we are never looking at now. We are always peering into a museum of light, where every exhibit is an artifact from some other time. But this was not just any artifact. The star's light had faded, its material body destroyed, but its final breath still moved through space, uncorrupted by the absence of its maker. The origin was gone. The evidence remained. In the quiet rooms of the observatories, the astronomers began to ask questions. Could other such signals be out there, still wandering from systems erased by time? How many stars, civilizations, or worlds might have left their faint shadows on the cosmic stage, only to have them arrive here in our era like bottled messages, washing ashore long after their senders had vanished beneath the waves? The phenomenon was not entirely unprecedented. After all, the light from galaxies billions of light years away is from galaxies that may have already merged or been reshaped. But this was different. This was not diffuse starlight, but a single coherent emission, as if one voice had carried across the silence, refusing to dissolve into the crowd. For the first time, the thought formed quiet, speculative, and unsettling that this might not be a random accident of the universe's physics. It might have been intentional. The data was not yet strong enough to suggest it, but the idea lingered, even if it was not deliberate. The persistence of this ancient whisper suggested something profound. Information, once cast into the void, might be immortal on timescales beyond imagination. As the months turned into years, the signal did not fade. It shifted slightly as the Earth's orbit around the Sun altered the reception window, but it remained stubborn, continuous, untouched by the death of its source. And so, the era of its discovery ended with a truth more enduring than the instrument that found it. The universe remembers. It remembers in light, in gravity, in the endless ripples of radiation that carry the signatures of the long gone into the yet-to-come dot. This was the first step into a mystery that would only deepen, a mystery that would demand new instruments, new theories, and perhaps a new way of thinking about what it means for something to end. At first, the discovery was treated as an oddity, a peculiar footnote in the vast ledger of astronomical observations. But as the data matured, and as the same spectral fingerprint continued to be recorded year after year, the oddity hardened into a paradox. It was not the presence of the signal that disturbed the scientists. The universe is full of radiation, whispers and echoes, but rather the absence of its source. When a star dies, it leaves behind traces, a white dwarf cooling slowly over billions of years, a neutron star spinning silently in the dark, a supernova remnant, an expanding shell of gas and dust that serves as the visible tomb of what once was. And yet, when the astronomers aimed their most sensitive instruments toward the coordinates from which the signal came, they found nothing. No remnant, no echo in the optical spectrum, no X-ray signature. The region appeared quiet. Too quiet. The calculations told a strange story. Based on the signal's redshift, the stretching of its frequency due to the expansion of the universe, it had left its source hundreds of thousands, perhaps millions, of years ago. Even the most generous estimates placed the origin's destruction long before the first humans stood upright on the plains of Africa. Here was the shock. The scientists were not observing the present state of an object as one does when looking at a star. They were receiving a living broadcast from something that had ceased to exist in every meaningful way, an event so far in the past that no telescope, no matter how powerful, could ever catch up to it. It was as if a voice was still echoing through a valley long after the speaker had stepped beyond the mountains and disappeared into history. This was more than just an academic curiosity. It was a direct confrontation with the nature of time itself. Every astronomy student learns that to look into space is to look into the past. The sun's light is 8 minutes old. The nearest star's light 4 years old. The most distant galaxies billions of years old. But this was different. This was not merely an image preserved in transit. It was an active, coherent signal, still in motion, still carrying the fingerprint of its long-dead origin. The paradox was sharpened by the rules of causality. Physics teaches that effects follow causes, yet here was an effect, a signal arriving in an era when its cause no longer existed. Of course, Einstein's theory of relativity leaves no contradiction here. The death of the source and the arrival of its signal are both consistent in the space-time picture. The signal is simply light, traveling at light speed, obeying the cosmic speed limit. But emotionally, for those who studied it, there was something deeply unsettling about watching the present behave in ways that seemed to mock our everyday intuition. And there was another wrinkle. The signal's coherence. Its unchanging pattern suggested stability over an extraordinary period before the source's death. Stars, even the most regular emitters, have lifespans defined by turbulence, magnetic storms, stellar winds, and gradual decay. The signal's endurance hinted at a kind of clockwork precision. Such stability, while not impossible for certain astrophysical objects, was unusual. Some proposed that it might have originated from a pulsar whose beam had, by sheer coincidence, been aimed at Earth for a long epoch before a catastrophic collapse. Others wondered whether it could be the remnant emission of a neutron star being slowly absorbed by a black hole, the final pulses still escaping before the event horizon claimed them. But these ideas stumbled. Against the observational void, there was simply nothing there anymore to study. Whatever had happened, it had erased the source with near-total finality. The more the scientific community turned the data over in their minds, the more unsettling questions emerged. If this signal had survived its source, how many others might be wandering through the cosmos, evidence of vanished worlds, extinct civilizations, or cataclysmic events? Was the universe filled with these ghosts, and had humanity simply been too deaf to hear them until now? There was a particular unease in thinking about civilizations. In the 1970s, the search for extraterrestrial intelligence SETI had already considered the possibility that humanity might one day receive signals from extinct alien cultures, their transmissions still on the way, while their cities, oceans, and skies lay silent in some long-dead system. But this was no science fiction speculation now. This was a real signal from a real place, whose silence was not metaphorical but absolute. For some scientists, the shock was intellectual, the encounter with a perfect, textbook example of how light preserves the past. For others, it was personal, a sudden awareness that the same principle applies to us, to our world. Long after Earth is gone, our light and our noise will continue outward, carrying traces of who we were into the deep future, perhaps to be intercepted by beings we will never meet. As the shockwave of this realization spread, a kind of philosophical vertigo took hold. The astronomers were no longer just measuring wavelengths and plotting graphs. They were grappling with the nature of memory in the universe. If the cosmos retains the past in the form of traveling light, then nothing is ever truly gone. But if that is true, then nothing is ever truly here either. We live, it seemed, in a constant procession of ghosts. Every star we see, every galaxy, even the moon above our heads, is already a relic of a vanished moment. And this signal was the purest ghost of all. What made it all the more unnerving was its persistence. Year after year, even as instruments improved and technology advanced, the signal's structure remained unchanged. It became a kind of silent companion to those who worked in the observatories, a constant reminder that the past is still out there, making its way toward us at the only speed it knows. The deeper implication was one that few wanted to voice too publicly. If the universe is a vast archive of such messages, then to search the sky is to search not for what is, but for what was. And perhaps, somewhere in that archive, there might be messages, deliberate or accidental, from minds that have long since passed into oblivion. The signal that had outlived its sender was no longer just a curiosity. It was a crack in the familiar narrative of astronomy, through which poured a blinding light of possibility and a creeping darkness of loss. The early years of observation brought clarity only in the most literal sense. The signal was real, stable, and unrelenting. But clarity is not the same as understanding. The deeper the scientists stared into its structure, the more elusive the truth became. It began with the basics: high-resolution spectroscopy to measure its exact frequency, down to the smallest drift. Cross-checks with archival data to see if this same spectral fingerprint had been caught accidentally in older surveys. Mapping its precise arrival time over the course of Earth's rotation and orbit, filtering out every conceivable terrestrial interference from satellites, aircraft, even faint echoes of planetary radar sweeps. The data told a strange story. The signal's frequency was steady, unnervingly so, with only the smallest redshift, drift consistent with the expansion of the universe and the slow motions of the Milky Way. There were no irregular flares, no chaotic bursts. This was not the erratic heartbeat of a dying star, but the patient rhythm of something that had once been remarkably constant. To trace its origin, the team triangulated using multiple observatories across the globe. They narrowed the source to a tiny region of sky, smaller than the apparent size of the moon. Within that patch, deep sky optical images revealed only a scattering of dim, ancient galaxies, their light worn thin by distance. The next question was distance itself. If they could measure its exact redshift, they could estimate how long the signal had been traveling, and perhaps what stage of cosmic history it had come from. Using the Atacama Large Millimeter-Submillimeter Array in Chile, astronomers analyzed the minute frequency stretch. The result? It had been on the move for at least several 100,000 years, possibly millions. The realization struck with quiet force. When this signal began its journey, humanity did not yet exist. The Sahara was a fertile plain, and the continents were arranged in shapes both familiar and alien, and somewhere far from our young world, a star or system was alive enough to produce this whisper. That life, stellar or otherwise, was now gone. But it wasn't just distance and age that fascinated the scientists. It was the distortions. The signal bore the fingerprints of its long voyage. Microscopic fluctuations in its frequency hinted that it had passed through clouds of interstellar plasma, which subtly bent and delayed its path. By modeling these distortions, researchers reconstructed a partial map of its journey, tracing it past regions dense with dust, then through near-empty corridors of intergalactic space. One anomaly in particular drew their attention. In several observation runs, the signal seemed to arrive in two faintly offset versions, the same pattern, duplicated but slightly delayed. At first, this was dismissed as a glitch, but repeated detections from different observatories confirmed it. The signal was being split by gravitational lensing. Somewhere between the source and Earth, the path had been bent by the immense gravity of a galaxy or cluster, creating two slightly different routes, and thus two different arrival times. The implications were staggering. By analyzing the time delay between these echoes, the team could probe not only the distance to the signal, but the mass and distribution of whatever object had bent it. In essence, this ancient broadcast had accidentally carried with it a measurement of the invisible structures of the cosmos, a postcard stamped with the fingerprint of a distant gravitational giant. Yet, even with these findings, the central mystery deepened. Lensing meant the scientists were receiving not just a single moment of the signal's past, but potentially multiple frames from different points in its history. If they could isolate the most delayed copy, they might be able to hear an even older version of the signal, a recording of a time before the source met its end. Weeks turned into months of computational work. Massive arrays of servers chewed through the data, separating the two signal paths, comparing them for subtle differences. patterns began to emerge. The earlier version was fractionally stronger in certain harmonics, as though the source had been fractionally more luminous in that ancient moment. But the changes were minuscule, almost lost in the noise of cosmic background hiss. And then came the surprise. One analysis, cross-checked obsessively to rule out error, suggested that the signal's intensity wasn't perfectly constant over time. It pulsed, faintly, on a cycle too slow for a pulsar and too regular for a quasar flare. The periodicity was measured in years, not milliseconds. Such a rhythm could indicate a binary system to massive bodies orbiting each other, their combined emissions rising and falling as they moved. If that were true, the death of the source might have been violent, the merger of two stellar corpses, perhaps neutron stars or white dwarfs, releasing an extraordinary burst of energy before falling silent forever. The signal they now heard would be the long tail of that system's stable emission before its catastrophic finale. The more they reconstructed, the more the signal became a biography. Its youth, steady, ordered, precise. Its middle age, gradual dimming, faint modulation. Its end, abrupt disappearance. A line cut clean in the fabric of spatium, but the biography was incomplete. Too much was lost in the scattering, the lensing, the distortions of its journey. It was like trying to read a burned manuscript, piecing together the story from the margins that remained. The search for answers expanded beyond Earth. Data from space-based telescopes, freed from atmospheric interference, were added to the mix. NASA's Deep Space Network, originally designed to track interplanetary probes, began quietly logging the signal when Earth's rotation brought it into view. Meanwhile, instruments designed to hunt for fast radio bursts were repurposed to listen for possible companions to this one lonely beacon. If the signal was one of many from the same region, perhaps a cluster of such remnants could be found, each a shard of a shattered system. No companions were found, no repeaters, just the one, and so the investigators turned inward to the signal itself. They stripped it to its rawest form, analyzing every microsecond for structure that could hint at either natural processes or, though they spoke of it rarely, artificial intent. Here, science brushed against philosophy. If the signal were artificial, it would mean we were listening to a deliberate broadcast from something that had since ceased to exist. That thought of a final message outliving its makers carried both awe and a certain grief. And yet, without clear modulation or encoding, the artificial hypothesis remained speculation. The data could not rule it in, but neither could it rule it out. In the end, the deeper investigation did not dissolve the mystery. It only expanded it. What began as a faint point on a spectrogram had become a map through space and time. A tangled, beautiful, and incomplete story carried on a wave of light. The scientists knew more about its journey than they did, about its origin. The one certainty was this: the signal was older than humanity. It had crossed gulfs of space where no probe, no ship, no eye had ever gone. It had been bent by gravity, slowed by plasma, split into echoes, yet remained coherent. It had carried with it the signature of a place that no longer existed, a ghostly embassy from a vanished moment in the universe's history. And still, every night when the Earth's rotation brought that part of the sky above the horizon, the observatories would turn their dishes toward it, and there it was, unwavering, unchanged, still arriving, still telling the same ancient truth. Something was here, once. The deeper they studied it, the less it resembled a mere curiosity. The signal, once just a faint blip on the spectrum, began to reveal itself as a kind of cosmic time capsule, not simply surviving the death of its source, but telling a story that stretched into the heart of the universe's most puzzling forces. It was during a cross-comparison with data from unrelated deep-field surveys that the first true escalation occurred. A research group in Europe, combing through high-frequency gravitational lensing data, noticed a peculiar alignment. The galaxy cluster that had bent the signal's path was itself part of an unusually dense filament of dark matter. This wasn't unusual in itself. Most massive objects are, but the density here was extreme. Simulations suggested that the bending of space-time in that region would not only split the signal, but also delay its arrival by centuries or even millennia. Between paths, this meant that some of the copies of the signal Earth was receiving might not have even left their source at the same time. The observatories were not just looking into one moment of the past, they were watching multiple versions of it, staggered across time. The implications were profound. In theory, it meant that somewhere in the future, decades, centuries from now, Earth might still receive new parts of the same broadcast. Long after the signal's original emission had ended, it was a revelation that made the scientists feel as if they were looking into the pages of a book that was still arriving, chapter by chapter, on the cosmic wind. But the mystery deepened further. Careful spectral analysis revealed tiny, periodic shifts in the signals, polarization changes so slow they could only be detected after years of accumulation. At first, these were attributed to interstellar medium effects, but the patterns didn't match random plasma interference. They matched something else, the gravitational tug of an unseen massive object near the signal's original path, possibly a black hole. If that were the case, then the signal had not only been lensed by a galaxy cluster far away, but also skimmed dangerously close to a much smaller, denser object in its home system before escaping into the void. That encounter, too, would have warped the signal structure, bending its path just enough to make the time delay between its versions even more extreme. One theorist proposed an unsettling possibility. If the signal had passed near the event horizon of a black hole, its time signature might be stretched by relativistic effects to an extraordinary degree. The version we were hearing now might be just a small fraction of the original emission, slowed by the warped fabric of space-time itself. In other words, the death of the source might not even have happened yet from the signal's own frame of reference, even though, in ours, it had ended eons ago. This was where the conversation began to touch the edges of physics that bordered on the philosophical. Could it be that this signal was more than a relic? Could it be, in some sense, still alive in its own time, still unfolding, still broadcasting, still in the act of being, even though its source had long since vanished from our observable reality? But even as the theoretical debates sharpened, the observational puzzles grew stranger. Multiple deep sky surveys returned an odd result. The space surrounding the signal's origin appeared to be expanding slightly faster than expected, a tiny but measurable deviation from the models of cosmic expansion in that region. It wasn't enough to rewrite cosmology, but it was enough to raise suspicion. Some linked it to the presence of dense, dark energy pockets. Others whispered about the possibility of a local variation in the cosmological constant, a phenomenon that, if confirmed, could upend our understanding of the universe's acceleration. And here, the scientists found themselves staring at a possibility they did not want to voice too loudly. What if the signal was not merely a survivor of its source's death, but a messenger from a region of space-time undergoing transformations beyond our current comprehension. If true, it would make this faint thread of radiation not just an archaeological artifact, but a living probe into the dynamics of cosmic change itself. As months turned into years, the mystery took on an almost mythic weight among those who followed it closely. In closed-door workshops and quiet conference corners, physicists speculated about scenarios that, if true, would place the signal in the company of the universe's most extreme phenomena. Perhaps it had been born in the final orbits of a binary neutron star system, its radiation carrying the encoded tremors of space-time itself. Perhaps it was the electromagnetic sibling of a gravitational wave that had long since passed through Earth, undetected in an era before our instruments could hear such things. Some even speculated about the role of quantum information. Could the persistence of the signal, despite its encounters with black holes, dense plasma, and gravitational lenses, suggest that information in the universe truly cannot be destroyed, that every event, every pattern, is written permanently into the quantum structure of reality? It was here that the emotional gravity began to weigh heavily on the researchers. If the universe preserves information this perfectly, then the cosmos itself is a vast, unending memory, a place where nothing, not even death, is absolute. The thought was beautiful, but it carried with it a quiet sadness. The signal's endurance was proof of survival, but also proof of solitude. Its sender was gone, its home was gone, and yet it wandered still, through millions of years and unimaginable distances, speaking only to the few who knew to listen. The final escalation came with a discovery that sent a chill through even the most seasoned astronomers. The signal's polarization shifts, when plotted against time with extreme precision, showed a secondary modulation, a pattern repeating not over years, but over centuries. The curve was incomplete, but its scale suggested something vast. Perhaps the precession of an entire system around a distant gravitational anchor, or the slow oscillation of a massive artificial structure. The latter possibility was treated carefully, almost reluctantly. Artificial origins were the territory of speculation, not claim. And yet, the data stubbornly refused to dismiss it outright, whether natural or not. The message was clear. The signal was not a simple, static artifact. It was dynamic. It carried with it layers of information shaped by forces, both local and cosmic. And because of gravitational lensing and relativistic delays, Earth might continue to receive new versions of it for centuries to come, fragments of a story whose ending had already been written in some distant, unreachable past. In the quiet of the control rooms, there were moments when the researchers would let the live feed of the signal play over the speakers, a faint hiss. The barest ripple of energy stretched across light years and ages. They knew they were listening to something impossibly old, impossibly far, impossibly alone. And still it arrived, every day, every night. It was no longer just a question of what it was, but what it meant. For physics, for cosmology, for the idea that anything, anywhere, can ever truly end. By the time the signal had been studied for over a decade, the sheer volume of data had transformed it from a curiosity into one of the most stubborn enigmas in modern astronomy. It was not just its persistence, but its layered complexity. The gravitational lensing, the subtle polarization shifts, the spectral stability, and the fact that its source had been erased from the sky long before human eyes ever existed to see it. The scientific community, unable to resist the gravity of the mystery, began to form camps. Some rooted themselves in the security of known physics. Others dared to push into the realm of the exotic. And in the space between these poles, theories bloomed like strange flowers in a cold and airless field. The most grounded theory was, in many ways, the most humble. The signal was nothing more than the dying echo of a once stable astrophysical object. In this model, the source had been a pulsar, a rotating neutron star with a magnetic field so strong it funneled beams of radiation into space. For a span of millions of years, one of these beams had swept across Earth's eventual position in the galaxy. Then, through some catastrophic event, perhaps the accretion of matter from a companion star, or the collision with another neutron star, the pulsar was destroyed, or transformed into a black hole. The beauty of this explanation lay in its simplicity. Electromagnetic radiation travels at the speed of light. The destruction of the source does not erase the waves already en route. The fact that we were detecting it long after the star's demise was simply a matter of timing and distance. But simplicity, in science, is not always truth. This model left too many details unexplained. The long-term stability, the precise polarization changes, the multiple lensing delays. It accounted for part of the phenomenon, but not all of it. A more elaborate theory centered on the idea of a binary system to neutron stars, or a neutron star and a white dwarf locked in a tight gravitational embrace. Over millions of years, the pair spiraled inward, radiating gravitational waves that carried away their orbital energy as they drew closer. Tidal forces could have amplified their emissions in ways we still do not fully understand. For a time, the system might have produced an exceptionally steady electromagnetic signal until, in their final orbits, they collided. The merger would have unleashed a short but intense gamma-ray burst, followed by silence. In this view, the signal we hear is the serene, stable radiation from their long courtship, preserved in flight, still arriving after their violent end. The gravitational lensing might be an accidental bonus, allowing us to receive staggered frames of their last millennia. Others argued that the signal's strange stability and longevity could be explained if it had originated near the edge of a massive black hole. In such an environment, time for the source would flow more slowly relative to distant observers like us, a direct consequence of Einstein's general relativity. From our perspective, the emission could be stretched across enormous spans of time, making it appear far more stable and persistent than it would to someone near the source. This theory even allowed for a paradoxical twist. In the signal's own frame of reference, the source might still be radiating. From our vantage point, we would be hearing the slow, drawn-out final notes of an object frozen in the gravity well of its own doom. A bolder camp suggested that the signal's consistency might hint at physics beyond the standard model. Some theorists proposed that it could be the product of a star or compact object embedded in a dense halo of dark matter. In such a case, interactions between normal matter and dark matter could, in theory, create a constant emission channel, one that persisted until the star's final destruction. In this scenario, the unusual acceleration of the space around the signal's origin detected in deep surveys might not be an observational fluke, but an effect of dark energy or dark matter dynamics playing out on a local scale. If true, the signal could be our first indirect probe of a hidden sector of the universe, and then there were the theorists who dared to touch the philosophical. In quantum theory, information is believed to be indestructible, a principle defended fiercely in the black hole information paradox debates of the late 20th and early 21st centuries Some wondered aloud whether the persistence of this signal might be a manifestation of that principle on a cosmic scale. Could it be that the universe remembers all events in some physical form, and that, under rare circumstances, those memories become accessible to observers far in the future? In this view, the signal was not just an echo, but a fragment of the universe's ledger, a page from the permanent record of reality. Drifting across the dark, few dared to champion this idea openly, wary of the stigma attached to it. And yet, in private conversations and late-night conference hallways, it surfaced again and again. What if the signal was artificial? Not a beacon meant for us, that would be too improbable, but a broadcast made for reasons lost to history. Perhaps it was a navigational signal for ships in a long-dead interstellar fleet. Perhaps it was the output of a planetary communication network, never meant to cross interstellar space. Or perhaps it was a deliberate message intended to endure, a monument built not of stone or metal, but of electromagnetic waves. The great irony of such a scenario would be that the builders might never have imagined that it would be received by beings who would not even exist until millions of years after they themselves were gone. The artificial hypothesis remained unprovable. There was no encoded content, no modulation that unambiguously indicated intelligence, but there was also nothing that conclusively excluded it. And for some, that sliver of possibility was enough to keep the thought alive. Despite their differences, all theories shared one profound implication. The universe is a place where endings are not as absolute as they seem. Whether born of natural processes, exotic physics, or ancient intention, the signal was proof that the past can survive into the deep future, that the moment something happens, it begins a journey that can outlast even the thing itself. For some, that was a comfort. For others, it was unsettling. It meant that, in some sense, nothing is ever truly gone. The light of stars, the noise of civilizations, the ripples of our every act, all of it keeps moving outward, carried by the indifferent machinery of space-amy, and somewhere out there, perhaps even now, signals from our own world are on there. Way to strangers we will never meet, in times we will never see. The signal had endured for centuries in flight, but the instruments capable of understanding it had not. Every telescope, every receiver that had once listened to it would eventually be dismantled, upgraded, or retired. And yet, with each generation of tools, the clarity of its voice improved, the first instruments to catch it. Ground-based radio dishes, built in the mid-20th century, could only scratch the surface of its detail. Today, entire arrays stretch 4 kilometers, each dish acting as one ear in a colossal, coordinated network. The Square Kilometer Array, SKA, still under construction in the deserts of South Africa and Western Australia, promises sensitivity orders of magnitude beyond anything before it. When complete, it will be able to detect a radio signal no stronger than the heat glow of a candle. From the moon, the signal's faintness is no longer a challenge. Now the race is to extract every scrap of information hidden in its structure. At Arecibo's remains in Puerto Rico, before its collapse, archival recordings were reanalyzed, mining the data for early traces. In China, the 500-meter aperture spherical telescope fast dedicates fractions of its schedule to the signal, pushing its vast steel skin toward the source's coordinates whenever conditions allow. The Very Large Array VLA in New Mexico joins in as part of international campaigns, each dish capturing a slightly different slice of the signal's arrival. These ground-based efforts are coordinated through the International Radio Astronomy Network, a loose but determined coalition of observatories across continents, united by a single, stubborn question. What is this? Every few months, the network convenes virtually, exchanging refined measurements, Doppler drifts, polarization changes, faint harmonics. Each new season of observation adds to a record stretching into decades, allowing slow trends to emerge that no single observatory could detect in isolation. Even the clearest mountain air Earth's ionosphere shifts the phase of incoming waves, and weather scatters reception. To escape these limitations, some listening has moved into orbit. NASA's Deep Space Network, originally designed to track probes like Voyager and New Horizons, now quietly logs the signal whenever its giant antennas are pointed in the right part of the sky. In higher orbits, experimental platforms, like the proposed Lunar Radio Array, could listen from the far side of the Moon, a shielded cradle of silence, free from Earth's electronic noise. From there, even fainter echoes, perhaps too weak to be detected on Earth, might be caught. The James Webb Space Telescope, though tuned for infrared light, has also been enlisted indirectly. Its precise imaging of the galaxy cluster lensing the signal helps model the exact gravitational distortions, allowing scientists to reverse engineer the signal's original profile before its long journey bent it into multiple arrivals. The raw data is almost incomprehensible to the human mind. Terabytes of numbers representing amplitude, phase, polarization, time delay. The real work is done in the invisible realm of algorithms. Machine learning models, trained on synthetic versions of the signal, hunt for structures that could be buried under cosmic noise. Some are looking for patterns. Others are simply trying to characterize the distortions caused by the signals. Long voyage simulations run on supercomputers model the space between Earth and the source, tracing paths through clouds of interstellar plasma, gravitational wells, and pockets of dark matter. By running the clock backward, they try to reconstruct what the emission looked like at its point of origin, stripping away the scars of distance. One simulation in particular caused a stir when run with certain lensing models. The reconstructed signal appeared to be not just steady, but modulated, faint, regular variations in amplitude over time. The result was not yet confirmed, and skeptics cautioned against premature conclusions. But the possibility that the signal might carry embedded structure reignited old debates about artificial origins. Perhaps the most haunting aspect of the signal is the knowledge that because of gravitational lensing, more of it may still be on the way. The time delays between its multiple paths could span centuries. Our era might be the first to hear it, but not the last to prepare. Observatories are archiving not just the data, but the methods, ensuring that scientists in the distant future, perhaps in the 2400s, can compare what they hear to what we hear now. The hope is that the later versions will differ just enough to reveal something decisive about the source, perhaps its decline, its final moments, or its ultimate silence. Some missions are even being designed with this timeline in mind. Deep space probes, like the interstellar probe concept, meant to leave the heliosphere entirely, could one day listen from vantage points far beyond Earth, catching the signal before it passes through the electromagnetic interference of our own planet. For all the technology, the pursuit remains profoundly human. In the quiet hours of night shifts, technicians sit before control panels, watching the live feed as the faint hiss comes in. Not sound, but converted for the ear nonetheless. It is easy, in those moments, to forget the machinery and think of it as a voice. Some scientists have worked on the signal for most of their careers, watching it outlast colleagues, research grants, even telescopes. They joke, sometimes, that the signal will still be here when they are not. And in that joke is an unspoken truth. They are studying something that will almost certainly outlive them. The next decade's efforts are focused on 3 fronts. Decoding structure. If modulation exists, is it natural or intentional? Tracing. Origin. Can its path be reconstructed precisely enough to pinpoint the remains of its source system? Measuring change. Will its characteristics shift subtly over time, revealing the physical processes at work before its death? The answer to any of these questions could rewrite our understanding not just of this signal, but of how information, energy, and memory behave across cosmic scales. The tools will grow sharper, the algorithms will grow wiser. But for now, the signal keeps arriving as it always has. Steady, faint, patient. A letter in a language we have not yet learned to read, addressed from a place that no longer exists, carried by forces as old as the universe itself. And still, every night, dishes turn in desert valleys, in mountaintop observatories, in orbit. Above the earth, they wait, they listen, they record. Because one day, tomorrow, or in some future century, the signal might finally tell its secret. In the dark, the signal drifts on. It does not know it is being heard. It does not know it is alone. It does not know its sender is gone. It moves through the universe with the same quiet inevitability as the turning of galaxies, the same patient certainty as the slow cooling of stars. It began in a place we will never see as it was. That place is gone now, dismantled by time, dissolved into dust, its light scattered into the untraceable haze of the cosmos. But the signal is still here. In its survival lies a truth so simple, so profound, that even the equations which describe it cannot dull its emotional weight. The past does not vanish. It travels. We imagine time as a river, always moving forward, its waters carrying us toward the unknown. But the universe reminds us that it is also an ocean, every moment still out there somewhere, rippling outward in concentric circles. This signal is one such ripple, the afterimage of a moment long extinguished, still spreading across the dark. The astronomers who listen to it know this. They know that when they tune their instruments to its faint whisper, they are not speaking to the present, but to a ghost. And yet, in that ghost there is life, not in the biological sense, but in the persistence of pattern, the refusal to dissolve into randomness. It is the same defiance found in the light of dead stars, in the gravitational waves from ancient collisions, in the slow warmth of planets whose suns have died. The philosophers speak of legacy, of how every act, every word, every breath leaves an imprint in the world around it. On Earth, such imprints fade quickly. Here, in the vacuum between galaxies, they endure. For millions of years, perhaps for the lifetime of the universe itself. A signal can travel untouched, a message without a recipient, a memory without a mind to remember it. And what of us? Right now, the Earth is broadcasting. Our television signals, our radar sweeps, the hum of our cities, the shouts of our transmitters, all of it is leaving this planet at the speed of light, fanning out in every direction. We are writing ourselves into the sky, whether we intend to or not. In 10,000 years, our voices may reach worlds where no one is listening. In 1,000,000, they may wander through empty systems, circling cold suns, In a billion, they may still be out there, a fossil of our presence, drifting without destination. The signal we study now is proof that such fossils endure. It is proof that the end of a thing does not erase it from the universe's memory. Even the smallest vibration, once set loose into space, becomes part of the great archive of reality. It is a strange kind of immortality, not the warm, conscious immortality of myth, but the cold endurance of physics, impartial, unfeeling, yet absolute. It does not preserve the mind that made the pattern, only the pattern itself. The sender is gone, the message remains. And yet, perhaps that is enough. Perhaps what matters is not that the universe remembers us as we were, but that it remembers we were at all. That somewhere in the darkness there will always be proof that we once stood beneath the stars, built instruments to catch their whispers, and tried to understand. In this way, the signal is not only a story of its sender, but a mirror held up to ourselves. It asks, without words, what will remain of you when you are gone? It asks, will you be heard? And if so, by whom? The scientists do not expect to find the sender. The coordinates where it once lived are empty now, their matter long since scattered into the galactic winds. Even if the system's remnants could be found, they would tell only the ending of the story, not the beginning. The signal alone carries that beginning, and even it carries only fragments. Still, they listen, because there is a strange, quiet beauty in knowing that even when something ends, it does not entirely disappear. It leaves behind a trace, a signal, a shadow of itself. And so, night after night, the dishes turn. They lift their metallic faces to the sky, and they wait. They wait for a wave of light that has been traveling for millions of years to cross the last, narrow gulf between there and here. They wait for the whisper of a place that once was, a place that will never be again, and yet somehow still is. In the cold mathematics of physics, there is no poetry in this. There is only cause and effect, emission and reception, velocity and time delay. But in the human heart, there is wonder, and in that wonder is the knowledge that we, too, are signals. Brief, bright, and moving outward into the dark, each carrying our own story. One day, far from now, our own signal may reach someone else. Perhaps they will not understand it. Perhaps they will. But they will know this, that once, long ago, in a distant arm of a quiet galaxy, there was life. And that life spoke, and its voice outlived it. The signal that outlived its sender is still on its way. And in a way, so are we.